Hello, I welcome you all to your own channel MSK Learning. In this video, we are going to discuss about the precessional motion. So precessional motion is nothing but that a form of motion that occurs when a torque is applied to a rotating body in such a way that tends to change the direction of its axis of rotation. Right, so that is the we can say the precessional motion. So precessional motion is nothing but the motion spinning of a body, right? So that motion we call it as a precessional motion. So that we will use in case of the gyroscopic effect and all those things. So first of all, you can write what is the precessional motion. So we can say a form of motion that occurs when a torque is applied to a rotating body in such a way that it tends to change the direction of its axis of rotation, right? So whenever a body is you can say subjected to a torque, right, and when it is rotating, so because of that torque it try to change its direction of its axis of rotation. That motion we call it as a precessional motion. So we will understand this precessional motion with one illustrative example. So now you have let's say you have a one axis, right, that is the OX. On this axis, one disk is rotating with an angular velocities of omega in anti-clockwise direction, right? So let's say this is your disk, okay, and this is rotating at an angular velocities of omega, right? This is the angular velocities omega, and this is rotating in anti-clockwise direction. So this is your disk. You can say this will be the disk, right? And you are viewing that how the disk is rotating from the front. So this is your direction of view, you can say direction of view, right? This is the direction of view. So now we can say that after certain time, let's say that after a small interval of time delta t, the disk has reaches to the new location, that new position, and that axis is nothing but the OX dash, right? So after delta time t, that the disk is reaches to here, and the angular velocities of this body is nothing but the omega plus delta omega, right? And the angular displacement, that how much the disk has displaced, that it is displaced by an amount of delta theta, right? So now you can say actually this is the axis of a spin we have right now. So that is the axis of spin, means the disk is rotating on this axis only. Now the new axis of a spin is what? The new axis of a spin is this one. So this axis, you can say this is your new axis of spin, means now the disk is spinning on this axis, that is OX dash, right? So now you have what will happen, that you can see that angular velocities is changes, means disk is changing its position in a certain time of delta t from omega to omega plus delta w. It means that the rate of change of angular velocities is coming to play. That means the disk has accelerated by an amount of angular acceleration, let's say that alpha, right? So that angular acceleration will be in the two direction, that is one is along the direction of OX, right, and one is the perpendicular to the direction of OX. Okay, so we have to we can say that there is the vector term, that this angular velocities and angular acceleration are the vector. So you can say the vector is this one, that is xx dash is a vector. You can find out the xx dash values, right? So xx dash values is what? That is nothing but the final angular velocities minus initial angular velocity. So if I show here on another line, let's say this is your means initial axis of a spin OX, right, and this is the new, or you can say the final axis of a spin, that is the OX dash, right? And here the velocity on this the velocity of the disk is nothing but, let's say this is angular velocity is omega, and the disk we have considered it is rotating in anti-clockwise. Now so here the angular velocities of is become omega plus delta omega, and the displacement which is covered by the disk is nothing but the delta theta, right? So if I say that this is your, and this will be reaches to this position. So this is like this. Okay, so this will be your x, and this is the r, right? So this is x dash r we have to calculate. Okay, now we can say this is the angular velocity ox, and this is the xr you have to find. So xr is what? That xr is nothing but, if you look at or minus ox, right? So you can say the vector, that the vector x dash means this x dash, right? The vector x dash represent the change in angular velocity, right? Angular velocity in time t, right? In small time interval delta t, in time delta t, right? That means the rate of change of angular velocity, you can say. So the rate of change of angular velocity is nothing but the angular acceleration. So you can say that is the angular velocity, sorry, that is angular acceleration. So the angular acceleration is what? Angular acceleration of the disk. So that angular acceleration will be act in the two direction. That is, one is along the direction of ox and one is the perpendicular to the ox. So first of all, we are finding the component of angular acceleration in the rotation of ox, right? So you can say that is the component of angular acceleration in the direction of ox, sorry, in the direction of ox, right? So this is what angular acceleration you can find, that alpha t is equal to xr by delta t. Xr is nothing but this one, right? That is from here to here. So you can say this value is what? That xr is nothing but, that is ox, right? Or minus ox. So you can write that is or minus ox by delta t. Okay, so or is what? That or is nothing but, if you see this or, right? So or is what? That component of this omega plus delta w, horizontal component. So horizontal component of this is what? That is omega delta w cos delta theta. Okay, now that you know. So you can say that is why, because means why we are finding the in along the direction, right? So you can say here that your equation will become like this: alpha t is equal to ox dash, right, cos theta, that is cos delta theta, minus ox by delta t. Okay, and ox dash is equal to what? Ox dash is nothing but the changes in angular velocity, which is omega plus delta omega. So you can say omega plus delta omega into cos delta theta minus ox by delta t. This ox is nothing but the omega you have, right? So when you open this will become omega cos delta theta, right, plus delta omega cos delta theta minus omega, okay, by delta t, right? Now so you can say that delta theta is very small. So for a smaller, cos theta is equal to 1, you can say, right? So you can say since delta theta is very small, right, is a very small, right? So we can say the cos delta theta is equal to 1. When you put cos delta theta is equal to 1, so this will become omega and this will become delta w, right, delta omega. So omega will get cancelled. So your equation will be that is omega plus delta omega cos delta theta minus omega by delta t, right? So this omega and this omega will get cancelled. So what is that? You have a, and cos delta theta is 1. So this will be delta omega by delta theta. This is the angular acceleration in the direction of ox we got, right? So that you can see that angular acceleration is what? Rate of change of angular velocities, right? Now we will find out the angular acceleration in the direction of perpendicular to the direction of ox. Before that, you can put the limit. So in limit delta t tends to 0, right? So the angular acceleration in direction of OX will be, you have a limit of delta t tends to 0, delta w by delta t is equal to, you can write dw by dt, that is d omega by dt, right? So this is your angular acceleration in the direction of OX, right? Now we can find out the angular acceleration in the direction perpendicular to the direction of OX, right? So you can write next that component of angular acceleration, right? Angular acceleration in the direction of perpendicular to OX, right? Perpendicular to OX. So now that is, you can say alpha c is equal to what? I'll show you that perpendicular to that is nothing but same, that is r x dash, right, by delta t. So rx dash means what? Rx dash is nothing but the vertical component of Ox dash, right? Vertical component of Ox dash is nothing but the omega delta w sine theta, right? You know, this is the basics of your physics, right? So here you can write alpha c is equal to what? That is rx dash by delta t, right? And rx dash is what? The vertical component of Ox dash. That vertical component of Ox dash is nothing but the Ox dash sine delta theta by del t. Okay, now so Ox dash is what? Omega plus delta omega, you can say. So now we can put that. Next you have a the same alpha c is equal to, that is in the direction of perpendicular to the OX, right? So it is what? OX dash means omega plus delta omega into sine delta theta, right, by delta t, So if you open, you can see that this is nothing but you have a omega sine delta theta plus delta omega sine delta theta, right, by delta t. Okay, now so you can say delta theta is very small, it means that sine theta is equal to delta theta, you can say. So since delta theta is very small, right, very small, hence sine delta theta is equal to delta theta. When you substitute this value into this equation, so the above equation, that is alpha c is equal to omega delta theta, right, plus delta omega delta theta by delta theta, right? Now if you see here, that is delta omega and delta theta. Delta omega and delta theta both are very small. So the product of the small is very much smaller. So the smaller quantity you are negligible. So the equation will become, that is alpha c is equal to omega delta theta by delta t, right? Why? Since you can write here, since delta w into delta theta is very small, right, is very small, right? Now therefore it is negligible. Just for the understanding purpose, you can write that why we have neglected, right? So because of the smaller values, we are neglecting that terms, right? So if you see that delta theta by delta t is what? The delta theta is nothing but the rate of change of angular displacement, and the rate of change of angular displacement is nothing but the angular velocity. So where the angular velocity? That angular velocity on the precision, right? So here you can say that is alpha c is equal to omega into omega p, right, where omega p is nothing but the angular velocities of precision, right? Omega p is the angular velocities of precision. Angular velocity of what? Angular velocities of precision. Okay, so angular velocities of precision, that is omega p is equal to v by r. So now if I find out the total angular acceleration of the disk is what, then you can say total angular acceleration of disk, means we have to find out the angular acceleration in the direction of OX and the angular acceleration perpendicular to the OX, right? So we have to simply add them. Total angular acceleration of disk, right, is equal to what? Is equal to, you can say, that is vector x dash, right, is equal to what? Vector sum of, that you can say the x dash is means what? X dash is nothing but your this one. I'll show you. Sorry, here only. That is x dash is this one, x dash, right? So that is the total angular acceleration. So you have a, just wait. So vector x dash is what? That is vector sum of alpha t and alpha c, means the sum of angular acceleration in the direction of ox and perpendicular to the direction of ox. So that we can got d omega by dt plus omega into d theta by dt. Actually we have to put limit tends to 0 in this, right? So that will become d theta by dt right now. So this equation will become like this. That is the total acceleration, right? So you have a total angular acceleration, right? So this is how we can find out the angular acceleration of a body when it is rotating on a axis OX and changes its position from OX to OX dash in a delta t time with an angular displacement of delta theta, right? So this is all about the today class. In next video we will see the gyroscopic effect. The gyroscopic effect we are going to discuss in aeroplane, naval ship, four-wheeler and two-wheeler. So for more updates, please like, subscribe, comment and share this channel. Thank you.